This is your Alex help video for assignment 12. I'm going to go ahead and start. Okay, so this is the exterior angle of a triangle theorem. The exterior angle is equal to the sum of the two interior angles. So in order to find x, you just add up those two and you get it. All right, this one, you're just kind of seeing that these two triangles are congruent and their corresponding parts are marked. So basically you go through the angles A, B, and C, match them up with their according to the arcs with which letter corresponds in the other triangle. So for example, angle A has one arc, angle X has one arc. So X goes there. And then B, you guys should be able to get it by then. So it is Z, oops, Z, and then you can do that one. Segment AB, so from the one arc to the two arcs, one arc to the two arcs is XZ. So I just have to type them in like that, XZ. The order should matter, so be careful on that one. And then at the end, you have to name the triangles. So if it's BAC, you look from B to A to C, the two arc to the one arc to the three arc, so the two to the one to the three. You just have to match it up. So in my case, it would be ZXY. Okay. Oh, I have to fill it in? Oh, no. There we go. I'm not really trying to complete the whole thing. Okay, so now we have a proof like we had in assignment 11. This one is partially given, so we just have to continue the proof. So if segment AB is congruent to segment CD, I notice that that is the given, and look at the diagram, it would be AB and CD. Unfortunately, you can't mark them, but it is basically the kind of like the top and the bottom segments. It says angle BAC is congruent to angle. I'm noticing that's in the given as well, but you have to fill in here. So BAC and then DCA, and that's given. And then it says side AC is congruent to side AC. Well, it's the same side. It's a shared side. You should know by now it's reflexive property. And then we're done. We just have to say, why are these two triangles congruent? So look at what's given, a side, an angle, and a side. Side, angle, side. You just have to search for the side, angle, side congruence property. And I'll check it just so you guys can see, and it is correct. Remember, pause as you need to. All right, so this one we are telling whether or not these triangles are congruent, and you have to name them in the correct order. They may not be congruent though. So on this first one, I'm seeing side, side, and side. So right away I can tell it's side, side, side. I just have to match them up now. So if the first one is MNO, I would start from this angle, which goes across the 2 mark line and then across the 3 mark line. So I want to start 2, 3, 1. So QPR. Dang it, QPR. Okay, so just basically do it like that. This one looks like side, angle, side, but this one, the angle should have been there, not here. So side, angle, side here, but not side, angle, side. So that one's no. And here it looks like angle, side, angle, angle, side, angle, yes, and then just make sure you mark them in the correct order from the 1 arc across the included segment to the 2 arc, from the 1 arc included segment to the 2 arc. Name them in the correct order. Actually, you have to follow this one, UVW. So it's like what I was saying, U to V to W. All right, next. All right, so on this one it says, it's the same thing. The congruent triangles, and then choose if it's side, angle, side, 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 angle, angle, side, or angle, side, angle. So this is a really good review of the different congruences. All right, here's another proof. Use the given information to prove that triangle RST is congruent to triangle VUT. So make sure you trace them and know what is congruent to what. So we are given this, just fill in what's missing. So I have to put in the UT, and then the angle our SRT. Okay, so that's given also. Okay, and then it says vertical angles property. Vertical angles are congruent. So it says RTS is congruent. The corresponding to R is V, so I would go to VTU. The order might matter. I don't know how specific it has to be on here. And then the last one, the triangles would be congruent. So you have to tell why, which reason. So we've got side ST angle from the vertical angles, and then angle R SRT. SRT. So angle, angle, wait a minute. Side in angle. Okay, so angle, angle, side. And then check it. Let's make sure it's right. Yes. It's kind of confusing because you can't write on it, but just look carefully at the side and then angle and then the angle. Angle, angle, side. Okay, and the next is, this one is just like that one, except it also has right angles. So I just want to remind you that this might come up, all right angles are congruent, but you'll actually be fine. E, F, that's given. So these proofs might be slightly different than the one that I did. Remember, you can always look for an explanation or see an example, and you can keep trying until you get it correct. All right, so here's number 8. All right, so this is similar, except now you have to actually type in the stuff. This is where you send to proof. So the given, send that to proof. So that's saying that side AC is congruent to side EC, so AC and EC. It looks like it was reflected across, kind of like C. And then send to proof, angle ABC is congruent to angle EDC. So these two angles. So we've got a side and an angle, and I'm noticing vertical angles are congruent. So we have to actually type that in. So the way I can name this angle, the vertical one is ACB. And then I have to do the congruent symbol to angle. So ACB, ECD. ECD. And then again, it's the vertical angles theorem, but in here they call it vertical angles property, and that's fine. Press validate and it checks it. So I've got side, an angle, and an angle. So I think we're done. It's ABC. So angle, angle, side. Wait, yeah, angle, angle, side. So I just have to say, I'm going to put the reason in real quick while I am thinking about it. Angle, angle, side, and then I have to name the triangles correctly in the correct order. So I would go for the bottom triangle, ABC, and then congruent to triangle. A is corresponding to E, and then I went to B, so it's EDC. EC. Just make sure you have all the corresponding parts in the same spot. Okay, it says my proof is complete. Let's check it. And it's correct. Okay, so here it is, just so you guys can see it one more time. Remember, you can rewind and fast forward as needed. All right, and then this one is similar, but I'm noticing it's a different kind of setup. So I'll go through this too. So send to proof, it's QR and SR are congruent. So it's that side and that side. Okay, next I'll send that to proof, that's fine. PR, segment PR bisects angle QRS. So PR is bisecting this angle QRS. So we have two congruent angles right there. So I already know the reason is going to be definition of angle bisector, because it was an angle that was bisected. Definition of, oh my goodness, angle. Definition of angle bisector. It's hard. Okay, so just keep looking and you'll find it. So again, I know it's an angle bisector because a segment bisects an angle. This angle is cut in half. So definition of angle bisector. So I just have to say what is congruent to what. So QRP, make sure you're picking angle. QRP. P. Sometimes segments are bisected, so just make sure you're paying attention if it's a segment or an angle. And then I went with Q first, so now I go S, R, P. S, R, P. Okay, so now I've got a side, angle, and then I need one more thing. I've only got a side and an angle. So I'm noticing they have a shared side. They share PR. So I'm glad I get to do this with you. I was having a lot of trouble with this little symbol for segments. So I click it and then I do PR. If I just keep typing in here, see how the line keeps going? It's going to count that wrong. So I don't want to keep typing. Even if I put a space, so I just hit the space bar, it makes the line keep going on top. So what you need to do to make it work is press the right arrow and then press congruent and see how the little segment symbol stops. It's really tricky, so make sure that you're doing that correctly. So anyways, do the side arrow, then the congruent, and then segment. PR is congruent to segment PR. The reason is, remember when they share a side, it's called the reflexive property, when it's the same thing congruent to the same thing. Validate, and now I can send a proof. And triangle PQR is congruent to triangle PSR by side, angle, side. You just have to look at what information did we have. It was side, angle, side. I'll validate it and check it. And if you're missing one little part, it'll let you fix it. So just go back and check carefully. Maybe watch the video again. And if it's just a really tricky problem, maybe you can get a new problem and it might be easier. So you can always do that. All right, so good luck with this and try for 100%. Okay.